Hello programmers. So in this lesson for CircuitPython and the Circuit Playground Luford edition, we're going to talk about for loops and we're going to work with ranges. You'll also have two challenge exercises at the end. One is going to be called turn on, turn off, and the other is called the brightness pulse. So let's get at it. Now we've been using a while true loop, and a while true loop creates an infinite loop. It executes our indented statements over and over and over again as long as our CPXB has power. But now we're going to learn about the for loop, and the for loop allows us to go through a set of indented statements a certain number of times. So here's an example of a for loop in Python. We're going to say for index in range 5 with a colon, and just like in our while true loop, everything that's indented after the colon will be repeated, but this time we'll repeat it 5 times. Now this index value over here is going to change each time we go through the loop. The very first time it's going to be a 0, the last time it's going to be a 4, so it's 0 indexed. We start at 0 when we go up to, but we don't include the 5. And by the way, this value index, we could give that any valid variable name in Python, but you'll most often see index, I, or x used. We'll change it up in some of our other examples. So here's how the code works. The first time we go through the loop, index is equal to 0. And when index equals to 0, we'll pass it down here, and pixels 0 will be lit up as purple, 255, 0, 255. Then we'll wait half a second. Then we'll go through the loop again, but this time index is going to be 1, so we update the second light here. Then we have index equals 2, index equals 3, and index equals 4. And at that point, we've gone through the loop 5 times. So let's hop over and give this a shot. Here I am in CircuitPython. I don't need my serial monitor to be up. I'll delete my code from the other exercise and enter the code that I just showed you on the previous slide. So here's our short program. I've plugged in my CPB. You can see it's still showing the blue code that I used in the previous exercise. We'll click on save. And now we turn on each of these lights in purple, light 0 through light 4, pausing half a second between turning on each light, and then our program is over. So our program's no longer running, but the lights are still on because our CPB still has power. Hey, what would happen if we put this in a while true loop? So let's give that a shot here. We'll say while true, colon, then I'll highlight these 3 lines and I'll press tab, and that will indent them. Now indenting these 3 lines after the while true loop means that these 3 lines are going to execute inside the infinite loop that is while true. But each time we go through while true, we're going to execute the for loop, which is going to go through and light up those 5 lights, light 0 through light 4. Now this is going to give me a result that's unintended, and I'll show you why, and we'll make a modification in just a bit. So now I'll click on save and watch what happens. We turn on lights 0 through light 4, and then the while true loop starts again, and that re-executes our for loop. And it starts at 0 and it goes to 4. It does it again and again and again. But because we've already lit up the 5 lights, we're not seeing the lights turn on again because we never turn them off. So what would we do in order to get the lights to shut off and then restart lighting up one at a time? Why don't you think about that? And let's do it together. So I want to turn the lights off, and I want to turn them off after I've turned on my first 5 lights. Now I want to make sure that I put my statement to turn off the lights so that it's not inside of the for loop. Because if it was inside the for loop, what I would be doing is I would be shutting off my lights each time I go through 0, 1, 2, 3, 4. And I only want to shut off all of the lights when I've lit up the lights 0 through 4. So what I can do is I can put my statement that turns off the light. And remember what that would be? That would be pixels.fill, and then with 2 parentheses 0, 0, 0, and then close 2 parentheses. But I'm going to make sure that that is indented even with the for loop. That means it's not going to execute inside of the for loop, but it is going to execute each time we go through the while true loop. So what that's going to do is it's going to light up 0 through 4, then shut them all off, then light up 0 through 4, then shut them all off, and continue in that pattern. So I'm going to click on save, and I see the lights light up 0, 1, 2, 3, 4. My loop is done. Then I blank out with the pixels fill 0, 0, 0, and I loop again. 0, 1, 2, 3, 4 lit up. Blank them all out. Now, we actually don't notice that that first light goes out, and the reason for that is we don't sleep after we turn the lights off. So we turn the lights off, and then we immediately turn that first light on again. So if we wanted to pause for half of a second, we could just add a time sleep 0.5 after we shut off all the lights. So then we'll see them off for a complete half second, and we'll restart the loop. And when we click on save, that's exactly what we see. 0, 1, 2, 3, 4, off, restart, 0, 1, 2, 3, 4, off, restart, 0, 1, 2, 3, 4, off, restart. So now we know how efficient loops are. So what I want you to do is to rewrite the code that we wrote during the last lesson, one blue at a time, but this time use a for loop to write more efficient code with fewer lines. And to remind you, this is what the pattern should look like. We light up all of the lights one by one, pausing 1/10 of a second after each light is lit up, shut them all off, pause 1/10 of a second, and we repeat the pattern. So why don't you pause right now, give it a shot, then unpause and let's take a look at the solution. So what we're going to do is we're going to go through 10 lights, and a range of 10 will go from index 0 to 9. And you know what I'll do is I said that we can change the value index in here. So I'm just going to change it to I, just so that you can see that that can be renamed whatever you want. We're going to turn our pixels into blue, so that's 0, 0, 255. Our time to sleep is going to be 0.1. And then what we're going to do afterward is we are going to turn all of the pixels to 0, 0, 0, which essentially shuts off all of the lights. We're going to sleep for 1 second, and then we're going to repeat. So let's see how this thing looks when we go ahead and click on the Save button. And this is looking great. And look at what we did. We wrote this with just a small amount of code versus the many lines of code we used in the previous example before we used the for loop. All right, let's take a look at a few more things that we can do with Python. And specifically, we're going to look at how we can change our ranges. So ranges don't have to start with 0. If you want to start with a particular number, you could use a range with 2 numbers in it. The first number is the start value, and the second number is the number that you go up to but you don't reach. So we'll go through 5, 6, 7, 8, 9, and not reach 10. So let's see what this code would look like if we executed it. We start over here at 5. So the first time we go through I is 5, so we light up 5 in red. The second time it's 6, the third time it's 7, the fourth time it's 8, and the fifth time it's 9. We never reach 10, we're done. So let's try it out just to see how things would work. So if we do 5, 10 here, we can actually leave our lights blue, but you know what, why don't we change them to red? And I'm going to go ahead and click on Save. Let's see how our code changes. And there we go, we're just lighting up pixels element number 5 through number 9. Good work. Hey, is it possible to have a range that would start at a value but skip values? Absolutely. That's what a 3-number range is. The first number is the value you start at. The second one you go up to but you never reach. And the third one is a step. That's the number that you increment by. So if we take a look, we'll start here at 0. We'll go up to, but we'll never reach 10. And we'll go up by 2s. So the first time we have 0, 2, 4, 6, 8. And then we stop, and you can see that we've lit up every other pixel. What about if we wanted to go in the other way? Can we go backwards? We absolutely can. Again, the first value that we have here in our example is 8. Then we're going to go all the way down to, but we're never going to reach -1. So that means we're going to stop at 0, and -2 is the number that we go down by. So let's give that a shot. We'll start off at 8, 6, 4, 2, and 0. Let's try them both out. So to start at light 0 and count by 2s, our range will be 0, 10, which we'll never reach, 2. And why don't we change the color to blue since we had red last time, and click on Save. Magnificent, look at that. Now what about if we go the other direction? So now let's change things up. Let's try a negative step. So why don't we start in light number 9, which we haven't lit up. -1 means we'll go down to but never reach -1, and -2 means we decrease by 2s. But if we start by 9 and go down by 2s, we'll be 9, 7, 5, 3, and 1. We'll never reach 0 either. And instead of lighting up in blue as we did before, let's change this to green just so that we can see the difference. And click on Save and give this a shot. And there we go in the opposite direction. Perfect! We've got ranges with 3 numbers. And now it's time for 2 challenges. So for our first challenge, what you're going to do is you're going to light up all of your pixels on your CPB. You can choose whatever color you want. You're going to go from 0 up to 9, and then you're going to go 9 down to 0, 0 to 9, 9 to 0, 0 to 9, 9 to 0. You're going to wait 0.1 seconds in between each color change. So after you're done with this, for my students, I want you to save the file as turn on off with dashes in between and submit that to Canvas. Now there's also a second challenge, and what you're going to be using here is the brightness command that we've never used before, but this is how it works. So if we've got a set of neopixels like we do, named pixels, you can say pixels.brightness equals 1.0 for full brightness, pixels.brightness equals 0.0 is all of the pixels are off, meaning 0 brightness. Now you can choose any color you want, but I want your CPB to behave like the one that you see here in the lower right. It's pulsing up from from 0 brightness up to 100%, and then it's going down from 100% down to 0 again, and it's repeating, and it's waiting 0.1 seconds. So not 0.1 seconds, but 1/100th of a second in between each increase and each decrease. Now here's a hint. So for loops can only take whole integers. You can't use decimal points in a for loop in CircuitPython. But you see, we need decimal points for brightness in here because we're going to go from 0.0 all the way up to 1.0, and we're going to do it by 1% increments. So what are we going to need to do? We're going to need to perform math. So if you want to set your pixel's brightness value equal to something, if you need to add or subtract or multiply or divide, the symbols are exactly the same as they are in Excel. Save this as brightness.py and upload it to Canvas. We got 2 challenge problems. I know you can do it. Keep at it.